Now next, let's go ahead and talk about one-sided limits. And to do this, or to introduce this, I'm going to look at a specific example. There are many examples like this one. This is an interesting situation that actually has a fun name. It's called the Heaviside function. Again, this is one that you've probably never heard of, but here's kind of how this is defined. This is actually a piecewise function, and it's defined like this. It says f of x is equal to 1 if x is greater than 0. So for all of the positive values of x over here, you just get the output value of 1. So just a horizontal line at 1. And as you might expect, based on the graph that I just drew, if x is less than 0, then your output value is negative 1. And the question is, what would we do in this case when we're talking about the limit as x goes to 0 of this function? Okay, and so remember what we would have done before is we would have tried to plug in a value or many values, not just one, but many values that are really, really close to the value of a. So in this case, a is 0, and we're saying as x gets really, really close to 0, or x is getting really small, what do you get as your output? And this is tricky because in this case, it actually depends on whether you're approaching 0 from the right-hand side, in other words, from positive values of x, or whether you're approaching 0 from the left-hand side, or in other words, from negative values of x. So if you approach from the right-hand side, from the right, it seems like the limit then should be actually equal to wherever there's actually an open circle there. It's not a closed circle because it's x is greater than 0, not greater than or equal to 0. But the limit there is still equal to 1. Like if you plugged in a decimal value from the right side, so 0.1, 0.01, 0.001, 0.000001, a decimal that gets really, really small, but that's positive, you get an output value of 1. But from the left, it doesn't seem like that's what happens. From the left, it seems like the limit as x goes to 0 of f of x kind of approaches this other open circle down here, and you're plugging in a negative value. So since you're plugging in a negative value of x, even though it's getting really, really, really close to 0, it's still negative, you're always getting negative 1 as the output. And so here's an example where you actually get something different depending on whether you're coming from the left side of A or from the right side of A. And that happens actually pretty frequently. And so this is why we need to talk about one-sided limits. And so notation from you, instead of every time writing out the words from the left or from the right, here's what that notation is going to look like. The limit as x approaches A of f of x. And when we're talking about, this means from the, I'll start with the left. I guess we usually think left to right because we read left to right. So from the left, let's start there. When we're using this notation to talk about the limit as x goes to a from the left, we use a little negative sign that is not in front of the a. Notice where the location of that negative sign, and it's really important. It's up in the top right corner of the a there. That means that we're talking about the limit from the left, or that's sometimes called a left-hand limit. Okay, it doesn't necessarily mean that a is negative, by the way. It just means that we're approaching a from the left. So think about on your number line. This is why visualizing a number line is really helpful, because typically the numbers that are, well, not typically, always the numbers that are negative are further to the left. So the left-hand limit has this little negative on it. Okay, whoops. So think about what is that going to mean if we talk about the limit from the right. Or you could also call that a right-hand limit. What do you think we would use as our notation? Okay, this one we're going to use the limit as x goes to a of f of x, but not a little negative sign now, because we're going from the right. Now we're going to use a little positive sign, and again, the positive isn't in front of the a, it's up in the top right corner of that a, to kind of say that we're using values that are specifically further to the right of whatever that a value is. Okay, so what we see in the last example, and what we'll see in a few different examples, is that the limit as x goes from the left and the limit as x goes from the right, they're not always the same. You don't always get the same thing. Okay, in fact, here's a kind of another example you could think of, it, one that you may have seen before, is to think about, I don't know, something like this. Like what about if you have something like this right here, and then you have a something like that. Okay, this is, again, kind of a piecewise defined function, and this is at the value of x equals 2, and maybe this output right here is 3, and this output right here is -3. Okay, and so if this whole thing was your f of x, what we would want to consider is what is the limit as x goes to a, or not a in this case, we know what a is, so let's go ahead and use a is 2 in this case. Remember, a is talking about the x values. What is the limit as x goes to 2 from the left of f of x? And what is the limit as x goes to 2 from the right of f of x? In this problem, we're actually going to get different answers because we're specifically talking about x going to 2. Okay, over here, let's say when you're going from the left, you would actually be getting, as x gets closer and closer and closer to 2, here's how I like to think about this in my mind. Approach 2, and the points on the graph are getting closer and closer and closer and closer and closer. To what point? Well, to that closed circle point. That closed circle point has an output of 3. Okay, what about as you go from the right? Well, as x gets close to 2 from the right, kind of think about plugging in values of x that are just bigger than 2, just barely bigger than 2. The points on your graph, if you go up or down and hit your graph, the points on your graph are going to be on this piece of your graph, and they're going to be getting closer and closer and closer and closer and closer to that open circle. Now, remember, talking about limits is different than talking about the domain. So it actually, and we'll see this in a little bit, it actually doesn't matter that there's an open circle there. All we're asking is, what are you getting really, really close to? Okay, so this problem here is really asking what's happening as you have f of 2.1 and f of 2.01 and f of 2.001 and so on and so forth, but these are always bigger than 2, just barely. What are they approaching or getting really close to? Well, f of x is getting really close to -3, even though there's an open circle there. It actually doesn't matter that there's an open circle. So something that we're going to see is that limits don't really care whether you have a hole or not. Limits don't really care about whether you have an open circle or a closed circle. We are just asking, what are you getting close to? All right, so at this point you might be asking yourself, well, wait a second, I thought in the first couple of problems we didn't have a little negative or a little positive. We weren't talking about the limit from the left or the limit from the right. So what's the difference between that limit at the beginning versus the left-hand limit and the right-hand limit? Because at the beginning, all we wrote was the limit as x goes to a of f of x, and now what we've introduced is the limit as x goes to a from the left, and we've been talking about the limit as x goes to a from the right. Okay, so these two, we want to be careful about, do we get something different from those? Okay, so do we get something different if you look at x going to a from the left versus x going to a from the right? And by the way, it does matter what a is. Okay, if you look at the last example and we have something like this, and it was when x was 2, if I asked you about the limit as x goes to -1 over here, there's no issues there with kind of the piecewise function. From the left and from the right are actually both going to exactly the same point. Okay, so it's only at that point of x equals 2 where we had that break where the left-hand limit and the right-hand limit gave us something different. Otherwise, the two limits there would have been equal. Okay, so we can think about kind of what does this mean when we have what I would call a general limit, not a left-hand limit, not a right-hand limit. I would call this one up here the general limit. Okay, and so the question is, how do we know whether that general limit exists. Okay, let me go back and look at the previous example where we had this situation where the left-hand limit and the right-hand limit gave us something different. So what if the left-hand limit and the right-hand limit don't give you the same thing? What if they're not equal? What if the left-hand limit gives you something different than what you get with the right-hand limit? Okay, so if this happens, okay, maybe for example, the left-hand limit gives you something like 3 and the right-hand limit gives you something like -3, then what we would say about the general limit up there of just x going to a, notice without a negative or a positive, of f of x, we would say that that limit as a whole, the general limit, does not exist. So that's a kind of a sloppy DNE, does not exist. So it is possible for a general limit to not exist. So how do we know whether a general limit exists or not? Well, it only exists if the left-hand limit and the right-hand limit are equal, if they give you exactly the same value. So let me write it like this. The general limit up here is equal to L if and only if the left-hand limit and the right-hand limit are both equal and are both equal to L also. Okay, so let me erase some of this a little bit and make sure things are a little bit more clear here. So the general limit is equal to L if and only if the left-hand limit, tablet's being a little slow, if and only if the limit as x goes to a from the left of f of x is equal to the limit as x goes to a from the right of f of x. And not only do they need to be equal, they both need to equal that L. So if we have a situation where the left-hand limit and the right-hand limit are not equal, then the general limit does not exist. So before we can talk about whether a limit even exists, we need to check the left-hand limit and the right-hand limit first. Okay? And oftentimes the left-hand limit and the right-hand limit are equal. The cases where they aren't tends to be things like piecewise functions, or functions where there are some kind of breaks or asymptotes or some kind of crazy behavior where that throws off that throws our function off at exactly that value of a. Okay, I think pretty much the last thing for this video, I just mentioned the word asymptotes, and so I want to think about kind of what happens in this case where maybe the two limits, the left-hand limit and the right-hand limit, maybe they're not equal, but maybe they don't just have one value there. You've seen a function like this. Here's a pretty common one. Something that kind of goes like this, and we know this is a rational function. This has asymptotes. And if I were to ask you something like, what is the limit as x goes to 0 of f of x? So for this function, this is, by the way, this is the function f of x equals 1 over x. You should have seen that one before in past classes. So think carefully, think about what we've talked about as far as left-hand limits and right-hand limits and everything like that. And for this one, you should say that the limit as a whole, notice there's no little negative or positive up here in the corner. So it's talking about the general limit when you don't see that negative or positive. The general limit here does not exist. Why? Well, because the limit as x goes to 0 from the right would actually give you something that is getting bigger and bigger and bigger. In other words, you can talk about here the limit as x goes to 0 from the right of f of x, but you don't just get a number like 2 or 5 or whatever. You would actually say here that the limit as x goes to 0 from the right of f of x is actually infinite. Then we could say, well, what happens as you take the limit as x goes to 0 from the left of f of x? Okay, so in other words, your x values are getting closer and closer and closer to 0, but you're on the negative side. Those are going down here. Okay, and so the limit there would be negative infinity. So remember, what do we need for the general limit here to exist? Well, we need the left-hand limit and the right-hand limit to go to exactly the same place, okay? And that does not happen in this problem.